Hello and welcome everyone. We're happy that we're all together again. In this very interesting tutorial, we will talk about a very exciting topic, which is the solar radiation and some concepts related to it, which will be very essential to us in our design. So fasten your belt and let's get started. The aim of this tutorial is to know what is the difference between the solar radiation and the solar irradiation, and we will learn also what are the different types of the solar irradiation, and finally we will learn how to calculate the solar irradiation on the solar panels to know exactly what is the most benefit that our solar system can get from the solar energy. So let's go ahead. The first thing which we have is the solar radiation, and the solar radiation is the power that the sun can supply to a specific area on the earth. But this power from the sun is in the form of electromagnetic radiation. So the sun radiation is a kind of the power, and as we know, the power is the available benefit from the sun. So when I say that the power that I get from the generator is 500 kilowatt, so this means that this generator is capable of giving a power or a benefit of 500 kilowatt. And this is regardless to what is exactly the consumed energy. So this is the generator or the sun ability to give me per unit area. And now to understand this concept well, we can compare it with the solar irradiation. Here the solar irradiation is the integration of the solar radiation, or in other words, it's the solar power consumed per specific period of time. So the solar irradiation is related mainly to the time, as we need to know exactly the amount of power that we have consumed. While on the solar radiation we were talking about the solar power that it can give us regardless to the consumed power or the real output power. And we must differentiate between the power radiation and the power irradiation, because not all the time in the day we are getting the benefit from the solar radiation. This is because there are some weather conditions during the day that makes it not available to get the most benefit from the solar radiation at all the hours. For example, in a day we will have a maximum solar radiation of 5 hours. Also, there will be another 4 hours of heavy clouds that will prevent that area from receiving the solar radiation. Also, for another 10 hours, the area that will have a night because the earth is rotating, so there will be no solar radiation in the night. So what we wanted to say is that the solar irradiation is the multiplication of the solar radiation with the time, because not all the 24 hours of the day we have a solar radiation. And this is the same idea of the generator when I say that the load that this generator feeds is working for 5 hours per day. So this means that the total energy consumed is 500 kilowatt hour per day. As you see, although the generator power is 100 kilowatt, but the power is not consumed all the day, and it's consumed according to the load. So at conclusion, the difference between the radiation and the irradiation is the same difference between the energy and the power. Now let's see what is the behavior of the solar radiation and the irradiation during the day. Here on the x-axis we have the time, and on the y-axis we have the irradiation from the sun. Now before 6 a.m. there is no sun as we are on the night, so the solar radiation at this condition is 0. And starting from 6 a.m. to 12 a.m., the solar radiation will increase gradually to reach its maximum value at 12 a.m. And the maximum value is good at this time because the sun will be exactly perpendicular to the earth, or it will be perpendicular to your location at this time. And when the sun rays are perpendicular to the earth, this gives us the highest radiation. Now after the peak value, the solar radiation will start to decrease gradually as the sun rays starts to decline step by step until the sun rays are parallel to the earth. Then the sun will disappear to get in the night, at which there is no sun, so there is no solar radiation. Now this is the difference between the radiation and the irradiation gradually, as the solar radiation is this orange curve here, while the solar irradiation is the area under the curve or the integration of the solar radiation during the time. So not all the day the sun is shining, or in other words, the irradiation has a specific period of time to have the radiation at which. But do you know, the solar irradiation itself hasn't only one type, as it consists of four types. The first one is called the direct horizontal irradiation, and at this type the irradiation is the irradiation that goes directly from the sun to the earth with no losses. So though solar irradiation faces no obstacle that prevents it from going to the earth directly, and it doesn't absorb it by any object. It just goes perpendicularly with an angle of 90 degrees and directly to the earth. Now the second type of the irradiation is the diffusion horizontal irradiation. And at this type the solar rays faces some obstacle through its way, like the clouds for example, or the atmosphere, so those obstacles absorb some of the solar rays energy and it reflects some other rays. So if the rays from the sun comes projected perpendicularly to the earth, when it faces some obstacle like the cloud, it will be scattered or it will fall on the earth with a declined or a tilt angle. So those types of the irradiation is caused when the rays faces, for example, some clouds or rains or mountains that reflects the sun rays. Now the third type of the irradiation is called the global horizontal irradiation, or its simple as S sub h, and it's nothing but the collection of the direct and the diffusion horizontal irradiation. So its name is global irradiation that contains two types of the irradiation. For example, some rays are falling directly to the earth and some other rays are scattered as they faces the cloud through their path. So the collection of those irradiation to the earth is the global horizontal irradiation. And this S sub h is very important type of the irradiation as we made our design according to it. So the global horizontal irradiation is a fixed value for each place on the earth, and we get its value each month from some standard tables. And it's logically to make our design on the global irradiation because not only the direct rays that falls on the solar panels, but also the diffused rays participate in falling on the solar panels. So those horizontal irradiation are supposed to fall directly on the earth with an angle of 90 degrees. And this will happen in the peak time of the place only, while the rest of the day the solar rays will fall on a specific area of the earth with a smaller angle of 90 degrees. Which means that there will be a smaller effect from the sun rays on the earth, as the effect is maximized for the perpendicular rays only. And as we mentioned on the previous tutorial, the equator of the earth is a special case as it's perpendicular to the sun rays at any time because its latitude is 0, while when going up and down the latitude angle increase until we reach 90 degrees at the north and the south poles. So for this reason the solar rays are not perpendicular to the earth's surface except the equator line. So at conclusion, at the equator we will get the most benefit of the solar rays, while when going up and down the solar rays starts to deviate or decline due to the deviated nature of the earth. So this is about the solar rays, and on the next tutorial we will illustrate the final type of the solar irradiation, which is the most important type as it's related to the design of the solar panels itself. Now I think that's enough for this tutorial. Hope that's it right now. Thank you for watching and see you next tutorials.